Hello there, everyone. So today, again, this is our final test, and I'm gonna do like a little review here just to refresh your minds about all the topics that we have been talking about for this last test. And just this is actually a small quiz. It's not actually a final test, and I do believe you're gonna do marvelously in this one. So let's see first our test. Let's see where it is. There we go. So this is our test. It says quiz. Yeah, this is our quiz. And it has three parts. The first one says solve two-step equations, show procedures. You have five exercises there. Then you have solve equations with like terms and parentheses, and then you have a few more. Then you have solve equations with variables on both sides, and then you have a few more. Then you're gonna have your bonus. In your bonus, it says write the verbal sentences as an equation, meaning that you're gonna read that sentence, you're gonna write that equation, and then you're gonna solve that equation. And depending on your results, that is the one you're gonna choose. This is for Monday, May 10, 2021. This is the due date, meaning that you're going to take the test today, Monday, and you're going to send it today, Monday. Now, there's no time limit doing today, but it has to be today. I will not accept a test for tomorrow. And of course, you have the Google form. And but before we go there, I really want to emphasize this part. In the following Google form, select the correct answers and upload a picture of your procedures. The format acceptable, again, you can upload a PDF or any type of image. Failure to show your work will automatically be grounds for failure of that exercise. And therefore, the test, meaning that if I do not see your math procedure, I cannot give you credit for your work, and if I cannot give you points for that work, and you do a bunch of them without the procedure, then you will fail that test. So please, please, please try to upload that procedure. And if you upload it to the Google form, it's a lot easier for me. So, and of course, you have a hyperlink that you can just click, and it will take you directly to your Google form. And this is, of course, for chapter 3, multi-step equations. Again, this is for May 10. The due date, it is on May 10. And again, the photos, if you have any photos that you're going to upload, please do it on the Google form. I would greatly appreciate that. So let's do a review, okay? Again, this is actually your test, right? I don't think you can see any answers there. This is how I put the equations there. And this is, you're just gonna have to choose at the end, of course, at the end, it has to upload your test. So let's go over and let's do some exercises, shall we? Give me a second until I can put the computer with my iPad here. So just give me a second. There we are. There we are. So let's do an exercise, okay? And try to do a variation of the same exercise so we can practice a few key components that we need to understand. So the first one is a very easy one. It is a two-step equation. And a two-step equation is something that you can solve in two steps. So for example, what if you have the number 46? That's a little bit small. Let me see if I can do this a little bit bigger. Cancel clear. Oops, sorry. Let's say, there we go. Let me try to do this a little bit bigger. So what if I have 46, there we go, equals 10 plus 2v. And you know that the v, it is our variable. And we want to solve so we understand, again, so we know what v is. We want to know, that is our objective, What is v? What is our variable? So the first things I need to do is I'm going to try to leave it by itself. And you know that when I undo an equation, the first thing I try to undo is like the reverse way of solving our pandas, right? So we are unsolving an equation. So the first thing I have to do is take away that addition or subtraction, wherever it is, between those terms, so I can leave just one term with our variable. So the first thing I would try to do is eliminate this addition by taking away that number 10. So I can take away that number 10, and then again, my 10 is positive, so I can eliminate it, right? I can take it away if I subtract 10, because 10 minus 10 is 0. But if I subtract 10 on one side of my equation, I have to subtract 10 on the other side of the equation. Why? Because I need to keep that balance between that equation. So everything that I do on one side, I have to do it on the other. And how much is 46 minus 10? That's going to be 36. So that was my first step. I just moved that 10 to the other side, basically. What do I have left? Well, I have a 36 equals 2v. Now I have less terms, right? How can I take away? Now I want to leave again that v by itself, so I have to take away that number 2. And it's being multiplied, right? So I have to undo that multiplication. The way that I can undo a multiplication is by dividing, and I can divide that by 2, the whole thing by 2. And of course, 2 over 2 is the same as 1, and 1 times v is v. So it is like if I were to cancel this. Again, but if I divide by 2 on one side, I have to divide by 2 on the other one. And how much is 36 divided by 2? 18, right? 18 equals v. And that will be my answer. I found out what v is. Now, let's say that maybe I'm not sure if I'm doing the correct procedures. Well, you know something? You can check them. I'm not going to ask you to do the checking on the test. That is, it is optional to you. But you can check it for yourself so you would know if you did it correctly. And again, the way that we check them is writing the original equation and substituting that v. So for example, I have 46 equals 10 plus 2v. And wherever I see the v, I can put my answer. What was v? V was 18. So now I can solve using my pandas. Remember my order of operation, meaning parentheses first, then exponents, then multiplication or division from left to right depending where they are, and addition and subtraction from left to right again depending when they are. So the first thing, again, I don't have a parentheses, not really, because this parentheses right here, what it's telling me is a multiplication is happening. So I don't really have a parentheses to solve. I don't have an exponent to solve, but I do have a multiplication right there. So that is the first thing I'm going to try to solve. I like to underline so you will see what am I solving for. And how much it will be then 2 times 18. Well, 2 times 18 is 36. What do I have left? Well, I still have left my 10 equals 46. And again, I'm just trying to figure out if both of the sides are the same. Now I can add them again. I don't have a multiplication, I don't have a division, so I can add or subtract from left to right depending where they are. And I have 10 plus 36, and 10 plus 36 is 46. And as you can see, 46 equals to 46. That is a very true statement. That is a true statement. Therefore, I did it correctly. Now, there are a few things that we did here. I don't know if you can see that we had to subtract that 10. What if my 10 was not um, positive? What if it was negative? What would I have done then? Well, I'll try to show. So for example, what if instead of having that positive 10, I would have a negative 10 minus, right? Minus 2v. Now this changes just a little bit. What if I had negative numbers, right? Again, if I had a negative number, I could not um, subtract that 10 because if I had a 10, right, and I subtract another 10, that would give me negative 20, right? And I don't want negative 20, I want a 0. So again, what I have to do then is adding negative 10 plus 10 is going to give me 0. That is what I'm looking for. But if I added 10 on one side, I have to add 10 on the other side. Now I can solve. 46 plus 10 is 56. What do I have left? Again, this is the first step that we did. What do I have left? 56 equals negative v. I cannot forget the sign. Remember, everything that is before it comes with that term. If it is plus 2v, then that means I have a 2v that is positive. If it is minus 2v, then I would have a negative 2v, 2mv, of course. Now, my next step, again, I'm going to try to take away that 2, and the only way I can do it is dividing by 2, right? But not just by any 2, because if I divide negative 2, if I divide it by 2, it's going to give me negative 1, and I don't want my v to be negative, so I have to make my 2 negative. Because negative number divided or multiplied by another negative number is going to give me a positive number. So again, negative 2 divided by negative 2 is going to give me positive 1. Therefore, I can cancel them and my v is going to stay positive. But again, if I divide on one side by negative 2, I have to divide on the other one by negative 2 also, right? Now, what do I have left? How much is 56 divided by negative 2? That's going to give me 28. And again, one is positive and one is negative, so that 28 is negative equals the v. And that will be my answer. Again, I can check this, of course. Of course, it's going to give me a different number to now. But again, I can check them by rewriting my original equation. and just substituting the variable. So for example, wherever I see the v, I can substitute it by negative 28 because I know now that that is going to be negative 28. Just like that. And now I can solve. Again, I don't have a multiplication. I don't have a parentheses because this parentheses is telling me that there's a multiplication, not to solve anything inside of that parentheses. I don't have no exponents, but I do have a multiplication, right? So that is what I'm going to try to solve first. And again, I take everything that is before that 2. I take the whole term. Negative 2 times negative 28. And again, I have negative times a negative is going to be a positive number. And 28 times 2 is 56. And I can put everything else just like it was. Now I am adding integers, right? There are different signs. And of course, we have a rule that it says, of course, that if I have different signs, I cannot add them. I will subtract them. But who is going to take the sign of what the result, which sign is going to be? Well, this result is going to be the biggest sign, right? I have a big positive number. I have a small little negative number. Therefore, I know that my answer is going to be positive, right? And how much is negative 10 plus 56? Again, they're different signs. Therefore, I subtract 56 minus 10. It is 46. It is 46. And I know that it's going to be positive 46 because my 10 is a lot smaller than my 56. And it is one way to see. And again, 46 equals to 46. That is a true statement. So we did it correctly. Now, what if I have an equation that has like terms? And again, what is a like term? Like terms, again, terms first is everything that is being, for example, a 3, a 2x, x to the second power. Everything that is being separated by an addition or a subtraction in an equation, it is a term. And like terms are, again, just like that sounds, there are terms that have the same combinations of variables and exponents. For example, if I have 2x plus 4x plus 2 plus 1, then I have here that 2x and 4x are the same terms. Why are they the same terms? Because they have the same variables, and both of those variables are to the same power, right? That would be 1, of course. They are to the same power. Therefore, I can combine them, meaning that I can add that coefficient. And again, coefficient is just that number that is being multiplied by the variable. So 2 plus 4, that will be 6x. That is how I can combine them together. But you know something? That does not mean that it has to have a variable for me to combine them. Again, constants, like we normally solve them, they are also like terms, and that's why we can also add them. 3 plus 1, 2 plus 1 is 3. So I can combine those two. Let's do some examples, shall we? So for example, what if I have the equation 2x plus 5 plus 3x minus 2 equals 18. Yeah, I know it's a little bit long, but it will make my point across. The first thing I have to do is identify the terms that are alike. I'm always going to try to um, simplify each part of the equation as much as I can before I start just moving things around. So I have here 2x and 3x, and those two are like terms. And I can rewrite this equation so my like terms can be together. That is an option. So for example, I can rewrite them. Again, I take everything that is before that 3x. I also have that 5 and negative 2 are like terms because they're both constant. Plus 5 minus 2. And then, of course, I put everything that it is on the other side of the equation. Now I can solve it, right? I can combine my like terms. 2 plus 3 is 5x. 5 minus 2, it is 3. Equals 18. Now I can undo this equation so I can find out what is x. And the first thing I can do is taking away that term, right? That extra term. How can I take it away? I have a positive 3. So the way I can take away a positive 3 is subtracting 3. 3 minus 3 equals 0. So therefore, I canceled it. But again, if I subtract on one side of the equation, I have to subtract on the next part of the equation, on the other side of the equation. And how much is 18 minus 3? 18 minus 3 is 15. So what do I have left? Well, I have left the 5x. I have left the 15. I have left the 5x. I have left the 15. I cannot use the 0, right? And now I have only one term and one term on each side of the equation. Again, it is being multiplied. So I can take away that 5 with the opposite operation. That will be division. So I have to divide by the exact same number. If it is positive, then I divide for the positive number. If it is negative, I divide for the exact same negative. Because I want to make that a 1. So I can cancel it. And I will have x equals, and again, how much is 15 divided by 5? That will be 3. Now let's say that I want to check my answer. I'm not sure. Let's say that I don't feel secure enough with my answer. I'm not sure if I did it correctly. Then all I have to do is rewrite the original equation and substitute the variable. So I have 2x plus 5 plus 3x minus 2 equals 18. And wherever I see an x, I can substitute it by what I know my x already, by the amount, right? Or what it means, that variable. And this time it was 3. Wherever I see that x, I can substitute that one by a 3. And now I can use my pandas, right? My order of operation. Again, I don't have a parentheses to solve inside of it. I don't have an exponent to solve for it. I do have multiplications, right? So the first thing I do is solve that multiplication. 2 times 3 is 6. And 3 times 3 is 9. Everything else stays where it is. Plus 5, it is positive, minus 2 equals 18. And now all I have here are a bunch of addition and subtraction. And again, I add and subtract from left to right in the order that they're on. So which ones am I going to try to do first? Of course, the 6 plus 5. And 6 plus 5 is 11. And I put everything else back where it's supposed to. Wait a minute. And I'm showing you like every single step of it, right? And again, I still have an addition. 11 plus 9, it is 20. Minus 2 equals 18. And 20 minus 2, that, and again, I'm underlining what I'm solving. I'm not dividing. That is just me underlining what I'm solving. And 20 minus 2 is 18. 18 equals 18. Therefore, we did that procedure correctly. If you have any questions, remember that you can always write to me through WhatsApp, and we can even meet through Zoom, and I can maybe show you some more examples, okay? Now, give me a second so I can erase this. And we'll do one with parentheses. Okay, so let's do one that has parentheses. We did one that had like terms, and now let's do one that has parentheses, okay? So again, when we have a parentheses, we always try to use the distributive property. And if you do not remember what the distributive property is, don't worry, I will go through that. So for example, in my example, let's say that I have 3, open parentheses, 5x plus 10, I close parentheses, equals 90. Well, again, now I have a parentheses, and I have to, again, I'm going to try to simplify the best as I can both sides of my equation before I can solve for x. So the first thing I do is I'm going to look inside that parentheses. Is there anything I can solve for it? Well, I have a 5x plus 10. They're different terms, therefore I cannot add them. I cannot combine them. I can only add or combine them when they have the same terms. If if 10 had an x, then I could add them. But because 10 does not have the same variables or exponent, right? That combination of variables and exponents that the 5 have, I cannot combine them. Therefore, I'm going to use the distribute property. And and the distribute property, what it says is that I'm going to multiply what I have outside with each of the terms that I have in the inside. For example, and I'm going to take everything that is in that outside, then it's going to be 3 multiplied by the first term. 3 times 5, how much is 3 times 5? 15. And the x, I'm just going to put the x, right? So I know that 3 times 5x is going to give me 15x. I'm going to do this in another color. And I'm going to do the same thing with the next term. 3 times 10, I know that's going to be 30. I'm going to leave everything else as it is. Now this is this is something that we have solved before. Again, we have a term, there are different terms. I want to leave that x by itself. So I'm going to try to get rid of that 30. How can I get rid of that 30? Well, I can subtract, right? Because positive 30 minus 30 is 0. Therefore, I can cancel it. But if I subtract on one side by 30, I have to subtract on the other one by 32, so I can continue to have that balance, right? And 90 minus 30 is 60. What do I have left? Well, I have left the 15x equals 60. And again, I have a multiplication right there. Therefore, I have to divide. So I can leave that x by itself. Again, if I divide by 15 on one side, I have to divide by 15 on the other one. This is going to cancel because 15 over 15, it is 1, right? And 1 times x is x. And 60 divided by 15 is 4. Now that I found out what is x, I can check my answer. And of course, all I have to do is substitute that 4 in that x in my original equation. Equals 90. So wherever I see the x, bloom, I'm gonna put that, it is 4, right? It was 4. So again, now I'm gonna look for my order of operations. Again, I have the pandas, right? Pandas, remember. Um, can I solve something inside a parentheses? Yes, definitely I can solve a parentheses. I have multiplication and addition. Which one comes first, the multiplication or the addition? The multiplication. Therefore, I'm going to solve for that first. 5 times 4 is 20. I'm going to put everything else as it was. Now, I don't have that multiplication. Even though I have multiplication there, I have to first solve for the parentheses. I have an addition, 20 plus 10, and 20 plus 10 is 30. I put everything else back as it was. And now I have a multiplication. Sorry. So you can see I have a multiplication. 3 times 30 is 90. Of course, 90 equals to 90. Therefore, I did it correctly. Sorry there. So we already have done two-step equations. We have solved equations that have same like terms. We have done equations that have parentheses, and we have solved them with the discrete property. We have also done equations. We have also have checked all the equations. So now let's do an equation that has a variable on both sides of that equation. So for example, let's say that I'm going to try to mix everything up here so we can practice even more. Equals 5x minus 6 plus 8. There we go. So let's say I have that monstrosity that teacher here has conquered, has made up, right? So the first thing I have to do, again, if I have a parentheses, I'm going to try to solve for whatever is inside of them. I cannot solve for anything that is inside them because they are different terms. Therefore, I'm going to use my distributive property. And now this one's a little bit different, right? Because I have -2. It is -2. Therefore, I have to use that sign so I will know the correct answer. So first things, I'm going to leave that 15x as it is. 15x. Now let's multiply. Let's do the distribute property. Negative 2 times 5x is, again, 2 times 5, it is 10. One is negative, the other one's positive. Therefore, this is going to give me negative 10x. The same thing I'm going to do with the 10. Now I have negative 2 multiplied by negative 10. Negative times a negative, it is a positive. 2 times 10 is 20. I hope you can see where everything came from. Equals. I'm going to do the same thing on the other side. Now my 3 is positive, so it will be positive 3 times 5x. And again, that is positive times a positive. So my answer is going to be positive. 3 times 5, that is 15x. And 3 times negative 6. Have a positive number times a negative number. Therefore, my answer is going to be negative 3 times 6. Sorry, 3 times 6 is 18. So it's going to be negative 18 minus 18. That's an ugly 8. Give me a second. There we go. And I'm going to leave the plus 8. Now again, now I have terms that are alike. Which ones are those terms? Well, 15x minus 10x, they both have the same variable. Therefore, they are equal terms. On the other side, I have two constants. They are the same terms, therefore I can combine them. Sorry. 15x minus 10x. 15 minus 10, it is 5x. And negative 18 plus 8, one is a negative, the other one's a positive. I am adding, therefore I have to subtract. That will be 18 minus 8 will be 10. Who is going to take the sign? The biggest one. 18 is bigger than the 8, therefore my 10, it is negative. And I put everything else where it is. What do I have left? Well, I had left the 20 plus 20 equals. And I have the 15x. 15x. I'm going to take away that 10. I'm going to put it a little bit closer. Minus 10. There we go. Now I can continue solving, right? Now I have two terms on each side of my equation. How do I solve it? Well, the first thing I want to do is try to take away those that next term, right? That is near my x. So I can look for what x is. So I'm going to undo the equation. The first thing I'm going to do is going to take that 10 and get it away from my 15 and maybe send it to the other side, like I like to say, right? So if I have negative 10, I would have to add 10 to make that a 0 and cancel it. But if I add 10 on one side, I have to add 10 on the other one. And 20 plus 10 is going to be 30. And that is one of the things I can do, right? What do I have left? Well, I still have the 5x plus 30 equals 15x plus 0, and I don't have to use a 0, right? Now I want to take away that 30. I want to take away that 5x from that 30. So all my x's are together, and all my constants are together. So I'm going to try to send this to the other side. Again, how can I do this? I have positive x, 5x. So all I have to do is subtract 5x. So it will give me 0. But if I subtract 5x on one side, I have to subtract 5x on the other one. This is going to cancel. I'm going to have left a 30 equals. And 15 minus 5 is 10. 10x. Now I still have a number next to that x. That number is called a coefficient, just in case you were wondering. I want to take it away from it so I would know what x is. They're being multiplied. So the way that I can find out what it is if I divide it. 10 over 10 equals 1. 1 times x equals x. But if I divide by 10 on one side, I have to divide by 10 on the other one. And 30 divided by 10, it is 3. I got my answer. Now let's say that I want to check that monstrosity. Oof. Then all I would have to do is wherever I had that x, substitute with a 3. So this could be a 3, this would be a 3, this would be a 3, and so on. I encourage you to check it. On the last part, you're going to have your bonus. Your bonus, it is something that we have been doing. This that we discussed on the sorry, on the how do you say that? I forgot the name of it. On the chapter quiz, sorry, on the chapter mid-chapter quiz review that we did. There is where we talked about this a little bit more. And again, what if I give you a equation in words? All you have to do is read it on the equation, write it down, and then solve it. So for example, let's say I have 7 times. I'm going to do this in colors, of course. 7 times the sum of 4 and a number Again, I don't know what that number is. Is, says here, is negative 14. There we go. So what if I have this? Again, 7 times the sum of 4 and a number. Well, I know that the sum of 4 is 4 plus a number. I don't know what number is, therefore I can use a variable. It can be any letter. 7 times that, 7 times that, that means I have to multiply by 7 all of that. Is negative 14, meaning it is another name for equal to negative 14. There, I built my equation. Now let's solve it so I will know what x is. Again, I cannot solve for what is inside of it. I have to use the distributive property. 7 times 4, that would be 28, right? 28. We look for another color. And 7 times x, it is 7x equals negative 14. Now I want to leave that x all by itself, so I'm going to take away that 28. So we have to subtract in 28. Will be 0. But if I subtract 20 on one side, I have to subtract 28 on the other. What do I have left? Well, I have left 7x equals -14 minus 28. They're both negative, so therefore I can add them, right? They have the same sign, I can add them. Which sign are they going to have? The one that is bigger, but again, in this time, they're both, if they were both positive, then my answer would be positive. If they're both negative, then my answer is going to be negative. Again, when I add or subtract, not when I multiply. Do not get them confused. And 14, right? -14 minus 28 is -42. -42. And I can, again, I want to leave that x by itself. It's being multiplied. So I divide by 7. If I divide by 7 on one side, I have to divide by 7 on the other side. What do I have left? In my left side, I have an x. And on my right side, I have a negative number divided by a positive number. And when they're different, my answer is going to be negative. 42 divided, negative 42, sorry, divided by 7 is going to be -6. And that will be my answer. And I can also check it wherever I see that x. I can always substitute for -6. Now let's go through some of the rules. Again, when I am simplifying a mathematical expression, the order of operation is as follow. Again, when I am simplifying something, I'm going to try to always follow that order of operation, where the first thing I'm going to do is try to solve for what is inside, for what is inside of the parentheses. Sorry for that. Here we go, make it a little bit bigger. There you go. So first thing I'm going to try to do is solve for what's inside the parentheses. Then any exponents that I see, the multiplication and division, depending where they are. Again, from left to right. If I see a division first, then I divide first, from left to right. If I see a multiplication first, then I multiply, depending on where they are. Then I can add or subtract. If I already solved for the parentheses, if I already solved for the exponents, if I already multiplied, if I already divided, then now I can add or subtract again in the same order that they are, from left to right. If I have addition, then subtraction, then I add first and then subtract. If I have subtraction and then addition, then I subtract first and then add. But when I'm on doing an equation, when I'm looking for what x is, I am undoing it. So the first thing I'm going to try to do is take away those addition and subtractions, then take away any multiplications or divisions that I see, any exponents and any parentheses. Again, it all depends, right? We just have to be smart about it. Now let's go through some of the rules of integers, and I know that this is what some of you have more trouble with. And these are a general idea of the rules for integers. Again, if I am adding a number that is positive with another number that is also positive, all I have to do is add them up and my answer is going to be positive. If I'm adding a number that is negative with another negative, right? And again, for example, 2 plus 4, sorry, that's technically 4. 2 plus 4 is 6. One is positive, the other one is positive. I am adding them, therefore my answer is positive. If they were negative, right? -2 plus -4. Again, I can't add them because they have the same sign. -2 plus -4, it is -6. Now, the thing is, the trick is that most of the time, you're not going to see the equation like this. You're going to see the same equation that looks a little bit like this. But it is the same thing. It is a negative plus a negative. A negative 2 minus 4. Again, I make it even more negative. This is the same as negative 6. Now you're going to say, Miss, but that is not the same. How come you can't just add them like that? Well, because there is a rule, right? When I do not have an addition, when I do not have that addition, I can change a subtraction by following the rules. Which are those rules? The rules of integers. And the rules of integers again says, I can leave the first one as it is. I change, right, that subtraction to an addition. But if I change it, I have to change, sorry, I was going to look for another color. I have to change the sign of the second one, right? And if it's positive 4, then I can change it to negative 4. And you will say, Miss, why do you always say that is a positive there? Well, because actually it is a negative, right? It's just that I always write it this way. That's why I say it's a negative. Just assuming that they're being added. Again, this is negative 6. Again, change the subtraction to the sign of an addition sign. How can you do it? The first one stays the same. You change that subtraction to an addition, but then you have to take the second number and change it from sign. And that is how you can, and then you can follow the rules of addition. You have a negative plus a negative is going to give you a negative. Keep practicing that one, right? Sorry, let me just erase this too. So we can continue with the rules of integers while we adding. The other thing is, again, if I have a number that is different to another one number, for example, what if I have positive 10 plus negative 2? Which one is bigger? Well, I know that my positive number is a lot bigger than my little itty bitty negative number. So I know that my answer is going to be a positive, right? Because it is bigger than the negative. And positive 10 plus negative 2 is the same thing as if I wrote 10 minus 2. It is the same thing. And 10 minus 2, right? If they're different, I just subtract them. It's going to be 8, positive 8. Because my 10 is a lot bigger than my 2, right? So again, what if I have a tiny little positive number? It is positive, right? Plus a very big negative number. Negative 10 is very big and that negative number. Well, I know then that my answer is going to be a negative number because my 10 is bigger than the 2. And I just have to subtract because they're different, right? 2 plus negative 10 is the same as 8 because I subtract them. It's going to be negative 8 because the 10 is a lot bigger. Now, those are the general rules for adding integers or changing these as a subtraction of an integer to an addition of the integer, right? But what if I was multiplying or dividing? Well, I do believe that it is even simpler if you were to add, multiply, or divide. Because signs that are the same is always going to be positive. And signs that are different are always going to be negative. For example, 2 times, and this is a multiplication, sorry. 2 times, and I like to do my multiplications with a dot because I don't like to think that the x means a variable, so I normally use a dot. 2 times, I don't know, 3, for example, they're both positive, therefore I know that my answer is going to be positive, and 2 times 3 is 6. If they were both negative, for example, -2 times -3, again, they're both negatives, therefore my answer is going to be a positive. That's going to be a 6 too. So you see, it's tricky. It's very different from adding or subtracting. If I was dividing, for example, if I have 10 divided by 2, they're both positive. This is going to give me 5, right? If I have -10 divided by -2, they're both negative. Again, this is going to be a positive number. Again, if they have the same sign, they're gonna have they are both gonna be positive. If they have different signs, what now? They're both gonna be negative. So for example, if I had um, -2 times 3, they're different signs, so I know that my um, product is going to be negative. And 2 times 3 is 6, right? The same thing, doesn't matter which one is bigger than which, they're both going to be -6 because they have different signs. And the same thing goes with division. Different signs, if you're multiplying or dividing, different signs, going to be negative, same signs are going to be positive. If you're adding or subtracting, specifically, right, if you are subtracting, you can always change that subtraction to an addition by just keeping the same number as it is, changing the subtraction to an addition, and changing the sign of the second number. Once you have that addition, then you can follow the addition rules. If they're both positive, my answer is going to be positive. If they're both negative, my answer is going to be negative. If they are different, then I don't add, right? I subtract. And that difference between those is going to be my answer. How do I know which one is going to be a positive and a negative? Well, if my positive is bigger than my negative number, then my answer is going to be positive. But if my positive number is smaller than my negative number, then my answer is going to be a negative. And that is the basic rules, right, of integers. And this is something that we have been working on since the first day of class. And that will be all. That will be all. If you have any questions or doubts, please feel free to write to me through WhatsApp. And if you need a more clarification, then maybe we can do a Zoom chat. I wish you all the best of luck. I hope to see you soon. And nothing. You got this. You know this. I'll see you soon. Bye.